I audible?
Yes, ma'am.
When does it started?
Ma'am, she is taking attendance now.
Mm,
It
okay
started at
then.
11, 12, 12. Sorry.
Okay, let's wait then. Okay, let's start. Uh, in the previous class, we see about conflict serializability and how two transactions are said to be conflict serializable. Means how two scheduling two or more transactions that is executing at the same time is said to be conflict serializable. So we see this also means in order to test whether a particular schedule is conflict serializable or not, or we use precedence graph. I mean, we can use precedence graph. So how to do this means how to see this. I have already told you to do it as an example, but I do not get means I only get one means answers from only a single student. So let me just tell you how to do this if you are still not able to get it. So for each transaction Pi participating in schedule L, create a not level Pi in the precedence graph, isn't it? So here this two example schedules are the example schedules we see in the previous class. So this is schedule number B and this is schedule number C. So for schedule number B, first let us draw the precedence graph for schedule B. Okay. So we have two transactions. We have two transactions here. Means two transactions is concurrently executing. So T1 and T2, we need to have two nodes. One node is for T1, one and the another node is for T2. So T1 and T2. This is your first step. For each transaction Ti participating in schedule S, create a node level Ti in the precedence graph. Okay. So the second step says that for each case in S where Tj executes the read item X after Ti executes the write item X. Okay. So for each condition, for each such cases, what we are going to do is we will create an edge from Ti to Tj. Okay. So a read and then a write. So here you can see this read. Here you can see this read. There is a read here, read X, and then we have a write X here. Okay, so here you can see where Tj executed read item X. So Tj is going to be T2. Okay, after Ti executed write item X. Okay, so yeah, so this is not the case. This is for another step. First, second step, read item, write item should be executed after the read item. So write item and then read item. Okay, here. Again, this is a write item and then a read item. There is no such cases here. For step number 2, we can't apply step number 2 here in this particular schedule number B because there is no write item, means there is no read item after write item. So write item, so there is no such case. So we'll skip this step number 2, we'll go to step number 3. For each case in S where Tj executes a write item X after Ti executes a read item X. So here we can see two such cases. The first one is this one, read item, and after that write item. Okay, so Tj is going to be T2. Tj executes a write item X. Tj executes a write item X after Ti executes a read item X. So after Ti is going to be T1. Okay. So after read item, a write item is executed by different transactions. Okay, by not by a same transaction. It should be executed by different transactions. Then create an edge from Ti to Tj in the precedence graph. So we have to create an edge from T. Here Tj is going to be T2 and Ti is going to be T1. Okay, so there is going to be an edge from T1 to T2. Okay. So this is by using step number 3. Let us see there is another such cases or not. Again, you can see here there is a read item X here and then a write item X. So here what is going to be Ti? Your Ti is going to be this this T1. What? So for each S, Tj executes a write item X. So T1 is going to be Tj. After Ti executes a read item X, and Ti is going to be T2. Create an edge from Ti to Tj. So there is going to be an edge from T2 to T1. Okay. Is there any other case, such cases? No. So we have we found two such cases which satisfy this step number 3. So we have created two edges. One is from T1 to T2 and another one is from T2 to T1. So we do not need to follow the other steps. We do not need to we do not need to see the other steps, because from here we can already conclude by using this precedence graph, because a cycle is already formed, isn't it? There is a cycle. Cycle is already formed, so we do not need to go through the other things. and so we can conclude that it is not serializable. Okay, this particular schedule number B is not serializable. We can conclude that. So for again schedule number C, we just perform the same thing. I will not read this. I will just try to draw the edges. Let us see. The knot is going to be T1 and T2. We'll have two knots, T1 and T2. Now there is a read item X here and a write item X. With item X and write item X, again it satisfies this step number 3 for each case. Here you can see Tj executes a write item X after Ti executes read item X. So Ti is going to be T1 and Tj is going to be T2. So there will be an H from T1 to T2. T1 to T2, there is going to be an H. Okay. Again, a read item and a write item. Okay. Again, there is a write item here and a read item here. So this satisfies step number 2. So for each case, Tj executes a read item X after Ti executes write item X. So here Tj is going to be T2, okay, and Ti is going to be T1. Again, there will be an H from T1 to T2. So there is already an H from T1 to T2, isn't it? So we do not need to create another H, but still, in order to make the graph as by following the rules, then let us just create an H from Ti to T1 to T2. Okay. Now, let us see for each case in S where Tj executes write item X after Ti executes write item X. So we also have that. This write item and this write item. This write and this write. So it satisfies this step number 4. Okay. So step number 4, there will be an H from Ti to Tj. Ti is again T1 and Tj is again T2. So there will be an H again from Ti to Tj. That is T1 to T2. Okay. So we have already checked all such cases which satisfy this steps. At last, the schedule S is serializable if and only if the precedence graph has no cycle. There is no cycle, isn't it? No cycle is formed. So that means this is serializable. This schedule number C is serializable. B is not serializable, but C is serializable. Okay, so this is how you are going to check serializability by using precedence graph. Now, let us see the concurrency control techniques. Okay, so concurrency control techniques, I already told you, means we already see what is the serializability, how the transactions work, what is the properties of transaction, everything, isn't it? And I told you that if the schedule is serializable, then what is going to be means there is not no inconsistency will be there. Okay, if two or more transaction is executing concurrently, and if they are executing by using a serializable schedule, okay, then there won't be any inconsistency. That means whatever concurrency control technique that we are going to have, it should be able to give a serializable schedule. Okay, that means it should guarantee serializability. Whatever schedule it will give should guarantee serializability. If it guarantees serializability, then it means in whatever concurrency control technique that we have, it is not going to lead, means it is going to be a correct concurrency control technique. Okay, means it will not be because of that concurrency control technique, we are not going to face any inconsistency or any other problem. Okay. So there are many concurrency control techniques. So we will see only 2 of them. And the first one is two-phase locking technique, and the another one is timestamp ordering technique. Let us see the first one, two-phase locking technique. So for that, we need to know what is lock. Log, so what is this log? So for each and every data that we have in our database, it is going to, it means a variable is going to associate with it. Okay, a variable will be associated with the particular data, and then, wait a second. Okay, so a variable will be there, and it is known as log. And what this variable says, that I will just read it out. A log is a variable associated with a data item that describes the status of the item with respect to possible operations that can be applied to it. Possible operation is going to be database operations, okay, like read, write, and anything update, whatever. So it means it is going to the log. This variable log will tell you the status of the item. Okay, whether we'll be able to read the item, whether we'll be able to write the item, will means that status should be given. Okay, and this status will be, we will see this status, we will be able to know the status of the item, and by using the variable that is known as log. Okay, so means whether we will be able to access the particular item or will not be able to access the particular item depends on this particular log. Okay, so there are types of logs. The first one is binary log. So for binary log, variable, the variable part, this is the variable, isn't it? So this particular variable might have two values, either 0 or 1. Okay, so if a particular data is having a log value 0, okay, listen carefully. For a particular data, if the log value is 0, then it means we will be able to access it. It may be either a read or a write, whatever. So we will be able to access it. If it is having a 1, if the value of the log is 1, that means it is log. The data is log, means it is already used by another transaction. Okay, that means this data is no more accessible. Okay, will not be able to access it because another transaction is accessing it at that particular point of time. So operations that means operations by using which the value of the log can be changed is, the first operation is lock item X, and another operation is unlock X. Okay, this is for this particular data X. We have to give the data here. So when the operation lock item X is executed, what will happen is in the table, there will be a table which will be saving the status of this particular status will be saved there in that table. Okay, so for this item X inside that table, for this item X, what is going to be the value of the log? It will be, we will be able to see it from that table. Okay, so when this log item X is executed inside the table, what will happen is like this. I'll just show you here. Table will be there. So suppose the table looks like this: data and log. So data might be A, B, say some, let us take some random value A, B, C. Log will be 0, 0, say it is having a log 0, 0, 1. A is having the log value 0, B is having a log 0, 0, C is having the log value 1. Okay, so what will happen is when operation log X, this log X is executed, what will happen? Let us see. So when log item when log item, say let us say the data A is executed, when this particular instruction is executed, this particular operation is executed, what will happen is this log value, it will change from 0 to 1. Okay, so it will change from 0 to 1. So if if a particular data is having a log value 1, it means it is already locked. If it is locked, then another transaction is will not be able to use it. Okay. So same thing, we also have another operation unlock X. So unlock whenever if there is a lock for a particular item, then we have to unlock it. Okay, a transaction is using this is going to use this data by executing this block item X. After using it, after whatever operation the transaction wants to perform, if it is already performed, then what will happen is this unlock X has to be executed. Okay, when it is executed, the one value will again change to 0. Okay, when unlock A is executed, this one will again change to 0, means it is available. Okay, if the value log is 0, then it means the data, particular data is available. Like that, there is another type of log, shared or exclusive log. It is also known as read-write log. Okay, another name is read-write log. So shared exclusive log means when we but for this again, the item will not look like this. It will be means the value is going to be either shared or exclusive log, like that, or unlocked. It will have 3 values. For this binary log, it has only 2 values, isn't it? It has only 2 values. But for or this type of log, shared, exclusive, or read-write logs, it is going to have 3 values. Let us say R, W, and unlock. For unlock, let us just take the value as U. Okay, so what will happen is a value, let us say, if every before executing anything, they are all unlocked. They are all unlocked. Everything is available. Every data in a database is available, isn't it? So everything is available. All the data are available. So what will happen is when with shared log or with this shared log is same as with log. Okay. And another name for exclusive log is write log. Okay. So when a read log is executed for a particular data item, read log A. When read log A is executed, what will happen is this U will be converted to R. Okay, so what does this read log or the shared log means? So if it is having a read log, okay, that means it can be shared by, means this particular data A can be shared by another transaction. Okay, because it is having the read log. What means when we have 2 operations that belongs to different transactions, and one of the operation is write, then only at that point time the operations is conflict operations, isn't it? Isn't it? So if 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 a particular means if we have to read, if two transactions is going to perform a read operation and another transaction is going to perform a read operation, if they are both read, then they are not conflict. They are not conflict to each other. So if they are not conflict, then they are not going to cause any inconsistency. Okay, so if a particular transaction is going to read a data item, then it means we can lock it by using the shared lock. So if it is having a shared lock, then another transaction who wants to read again this particular data item A, then those two transactions can share this data item because there is no such right is going to be performed. Only reads are going to be performed by two or more transactions. So no inconsistency will be there. Okay, so they can share this data. So that is why it is also known as shared lock, read lock or shared lock. Okay, if a particular transaction wants to perform a write operation. Hmm, I lost the connection. Let me just check it. Give me 2 or 3 minutes. Okay, so instead of read, if a transaction wants to write, then it has to it has to execute the write block operation. Write block set B. Then what will happen is if the unlock, this value will change to exclusive block and which is also known as write block W. If a data is locked by using exclusive or write block, then it cannot be shared. It cannot be shared. So no other transaction will not be able to access. It is not available. Okay. So read can share means if two or more transactions wants to perform the read operations to a single data item, then they can share by using the read block. Okay. And if a particular transaction is going to perform the write operation, then it has to use the write block and it will be exclusively locked for that particular transaction. No other transaction will be able to access it. So that is why two values will be there and there's going to be three values will be there for this lock and three operations will be there. One is read lock, write lock and unlock. Okay. So these are the types of locks that we have. Let us see rules for binary. So these are the things I have already told. Rules for binary locks. A transaction T must issue the operation lock item X before any read item X or I again lost the connection. Okay, so let us read this out. There are something I just told you. Transaction T must issue the operation lock item X before any read item X or write item X operations are performed in T. Okay. A transaction T must issue the operation unlock item X after all read item X and write item X operations are completed in T. Okay, so before using the item, before using a particular data, the transaction should issue the lock item X. Okay, and after using it, it should issue the unlock item X. Okay, a transaction T will not issue a lock item X operation if it already holds a lock on item X. If it is already holding a lock item X, if it is already holding a lock on a particular item, then it should not issue another lock because it is already holding it. It can access in whatever way it wants, isn't it? So it means it does not require to lock the item again. So this is the rules for binary lock, and let us see the rules for this one, uh, shared or exclusive locks or read or write locks. The transaction T must issue the operation read lock X or write lock X before any read item X. Okay, before reading, the transaction can either read lock or write lock. Okay, before reading. A transaction T must issue the operation write lock X before any write item X. So remember this. If it is going to if it is going to perform the write item, then it has to lock the item by using write lock. Okay, exclusive lock because it is going to write it. For reading, it can either lock it by using exclusive lock or by using the shared lock. For writing, it has to be the exclusive lock. A transaction T must issue the operation on. I don't know what is happening to this NIT internet. Okay, so the third one. Let us see the third rule. A transaction T must issue the operation unlock X after all read item X and write item X operations are completed in T. Okay, so these are just a simple few rules, first to third. Let us see the other one. A transaction T will not issue a read lock X operation if it is already holding a read lock or a write lock on item X. Okay, so just remember this one. If it is already holding a read lock or a write lock on the item X, it should not issue another read lock X. Okay, so when a particular transaction is holding write lock X on an item X, after some time it can also change the read lock X for some other, means this particular rule can be relaxed for some other reason. I will tell you the other reason later on. But for now, just remember this: if it is holding a lock, whether it is a read lock or a write lock, then it cannot issue another read lock. Same thing, If it is holding either a read lock or a write lock, then it cannot issue another write lock. Okay. The last one is a transaction T will not issue an unlock X operation unless it already holds a read lock or a write lock on item X. Okay, so this is also simple. If it should not issue unlock X if it is not holding any lock. So this is the rules for read write lock. So this particular thing, the rule may be relaxed. Again, here I have written this rule may be relaxed. Again, this rule may be relaxed. So when these rules are going to be relaxed, means lock read lock will be, the transaction will be able to change from read lock to write lock, and it will be able to change from write lock to read lock at what point of time. So if the system is having, means if is having the property of conversion on lock, okay, if it is allowed, if this particular conversion of lock is allowed, then lock upgradation and lock downgrading, it can be happen. Okay, it is possible. So for lock upgradation, a read lock means it can be changed to a write lock. Okay, so using some more conditions. Okay, if no one is holding write lock on this X, then it can be converted from read lock to write lock. Okay, same thing for here also, downgrading a lock, it is nothing is required for this. From read lock, no condition should not be checked here, means it doesn't leads to any problem, isn't it? So from write lock we can downgrade the lock to read lock also. It is also possible. If a particular system has the property of conversion of lock, then this is lock upgradation and lock downgradation is possible. So if it is possible, then only at that point of time this rule can be changed. That is rule number 4 and 5. Okay. So a transaction T will not issue a read lock X operation if it is already holding a read lock. This means if it is holding a read lock, it should not issue a read lock. But if it is holding a write lock, then it should be able to issue the read lock. Okay, and if it is holding a read lock, then it can issue a write lock. It can issue a write lock only if no one is holding write lock on that particular X. Okay, so this is going to be, this particular two rules is going to be means it will be relaxed if conversion of lock is possible. So you just read these rules. I'll give it means I'll share the class notes today or I think tomorrow maybe, and you just read it and you'll be able to understand it. It is not that difficult. So let us see what is this two-phase locking tactic. The transaction is said to be having two-phase locking protocol if all locking operations precede the first unlock operation. This is very important. See, all locking operations precede the first unlock operation in the transaction. So before unlock, before any unlock, all the locks should be performed. All the locking operations should be performed. Okay, before any unlock. Okay, so that is the part that is the definition, you can say, that is the rule for two-phase locking technique. So two phases will be there. It means two phases will be there. The first phase is expanding or growing phase. In this phase, all the locking should be done. Lock, all the lock, whether it is a read lock, write lock, whatever lock. If it is using read write lock, then it should be, all the read write lock should be done during this phase. After expanding phase, the shrinking phase will be there. Shrinking phase, this is for unlocking. Okay, during expanding phase, you can't have any unlock. Expanding phase has to execute first. After that, shrinking phase will be there. First, expanding phase will be processed. After that, shrinking phase will be there. Okay, so during expanding phase, no unlock should be there, and during shrinking phase also there shouldn't be any locking process. Okay, so it should be execute, means any transaction should be executed in this way, in these two phases. The first one is expanding phase and the second one is shrinking phase. So that is why it is also known as two-phase locking protocol or two-phase locking technique. Okay, so here you can see T1 not using two-phase locking. So why? We are having, means this transition is having a with lock Y. After that, it has an unlock Y. After that, it has a right lock X. Okay, so lock, there is a lock and there is another lock. In between, there is an unlock. Okay, so that is why it is not in the two-phase locking. It is not using two-phase locking technique. Okay, because there is an unlock here. And according to the definition of two-phase locking, we should have an expanding phase. After that, we can have the shrinking phase. Okay. And this is another transaction which is using two-phase locking. So with lock, whatever lock we want, we have to lock it first. And after that, if an unlock comes, then after this unlock, no lock item should be there. So there is no lock. No lock operation is performed after this unlock. Okay. So from here to here, it is shrinking phase. And from starting from here to this one, it is the, sorry, the first one is the expanding phase, growing, or you can say growing phase, and this one is the shrinking phase. Locks are expanding, after that locks are shrinking. You can take it like that also. Okay, so this one, so this two-phase locking technique, before means after this we have the another this one. This is the first this is the first concurrency control technique that we see so far. After that, we will have timestamp ordering technique. So this timestamp ordering technique we'll see in the next class, and in the next week, that is going to be, let us say, Monday, we'll be having, we'll have a unit test, the second unit test. Okay, and the topic will be till here, till this this one, transaction and concurrency control technique. After midterm, till this transaction and concurrency control technique. Okay, so this two-phase locking technique can lead us to deadlock. So how it is going to have, means how the transaction is going to be in the deadlock, let us see. Deadlock occurs when each transaction T in the set of two or more transactions is waiting for some item that is locked by some other transaction T1 in the set. I will just explain it here. So we are having, let us suppose we are having two transactions executing in the same time, T1 and T2. They are executing concurrently. Concurrently means they are accessing the same data, isn't it? They are going to access the same data. So T1 and T2 is executing. So if it is using, we are saying that both of them is using two-phase locking technique. Okay. So T1, suppose T1 is going to use X and then Y. And same thing, T2 is also going to use X and Y. Okay. So during the expanding phase of T1 lock this Y. Lock Y. Perform lock Y. Okay. After that, it reads Y. Let us see. At the same time, T2 perform lock X, and then it performs some operation on this X. Let us say read X. Okay. And after this read Y, what will happen? It can't unblock. It can't unblock, isn't it? Every lock has to be performed, and after all the operations that means after all the locks we have to the operations of unlock should be there, isn't it? So we can't unblock this Y, so it will try to lock X. It will try for this, and it will not succeed it because X is already locked by T2. Same way, it is going to try locking the data Y because it is going to use Y also, isn't it? So it will try locking the data Y. Okay, and Y is already locked by T1. That means it is trying to lock X, which is already locked by T2, and T2 is trying to lock Y, which is already using by T1. And it can't unblock. It can't unblock Y. Say suppose Y is already means T1 is already done using Y, and it has to unlock after some point of time. But before locking X, it can't lock Y. Why? Because it has to be following the two-phase locking technique. Okay, same thing for T2 also. It has to be following the two-phase locking technique, so it can't unlock this Y. This X. It means T1 is also waiting for T2. T2 is also waiting for T1 to unlock this Y. Okay, so at those times, if this particular situation is there, then a deadlock occurs. So here we are having the same thing. Deadlock occurs when each transaction T in a step of two or more transactions is waiting for some item that is locked by some other transaction T1 in the step. Okay, so this is deadlock. So this, if there is a deadlock, we can prevent it. How we are going to prevent this is means every transaction lock all the items it needs in how we can prevent it is whatever item that we need to lock, we'll check whether we can block it or not. Okay, the transaction is going to check it whether it can be blocked or not. Okay, if any of the item cannot be obtained, if it is not means it cannot be obtained, then it is not going to lock. Say suppose here before locking Y, before locking X, if T2 has already locked this X. Okay, and when T1 check for or before locking means before starting executing T1, what it is going to check is it will check whether all the data that it wants, whether it is X or Y, all the data that it wants is available or not. If any of the transaction is locking whether it is X or Y, then it is not going to start execution. Okay, so it will wait for that, and we can prevent this deadlock. And this again might lead to starvation. Okay, so a particular transaction might be waiting for or single data. All the other remaining data are available, but for a single data it is waiting. But if this particular data item is locked by one after another transactions, then starvation might be there. Okay, this is same thing you learn on your operating system. The concept is same thing. This is all theory. You can also read them. You'll be able to understand it. And for detection, we can use the wait for graph. Okay, in order to detect whether there is a deadlock or not. If Ti is waiting for some item which is blocked by Tj, then we have to create an edge from Ti to Tj like that. If there is a cycle in the wait for graph, then we can say that there is deadlock. Okay, like that we can detect it. You just read all these things. You just copy what are the things you need to read. Deadlock, how to prevent deadlock, how to detect deadlock, and then at what time starvation will come. Okay, so these are all theory. You can just read it out, and then you will be able to understand. Okay. So in the next class, we'll see timestamp ordering technique. If you have any doubt in two-phase locking technique and whatever details I have explained about lock, then you can tell me. Okay, then let me check your attendance.